Welcome back to another tutorial on business statistics using Excel. In this tutorial, I'm going to talk about two famous continuous distribution, including normal distribution and exponential distribution. In order to understand the concept of continuous distribution, we need to define the concept of random variable. A random variable like x is a numerical description of the outcome of an experiment. If we are doing an experiment that results in a discrete number, like rolling a dice, which result in discrete values, and build the frequency distribution over the result of this experiment, then we call it discrete distribution. If the experiment results in numerical value that are continuous values, like the height of the people, and we build the distribution over these values, then we call that frequency distribution a continuous distribution. In previous tutorial, we talked about discrete distribution. Basically, we calculated the percentage of the time that we can see the discrete value in our dataset. In discrete distribution, getting each of values for x has a separate probability, and if we add these probabilities, we can calculate the cumulative distribution. For example, let's assume we roll 5 die and we are interested to know the probability of getting 6 for x times. There is 40% chance that we get no 6 out of 5 trial, or 5 times rolling a die. There is 40% chance that we get 1 6. There is 16% chance that we get 2 6s out of 5 rolling die. And each of these bars shows separate probability or non-cumulative probability. They address the probability of x getting a specific value such as 0, 1, 2, 3, 4, or 5. So now cumulative probability calculates the probability of x getting a range of value. For example, there is 80% chance that we get 1 6 or less than 1 6. In another word, I'm adding up these two probabilities. So the probability of x being less than equal to 1 is either x is 1 or 0. And if these two are added, that results in 80% chance. So we call this cumulative probability because we are adding two separate probabilities. Similarly, the probability that x, number of sixes in 5 trials of rolling die, is 2 or less than equal to 2 is 96%. In another word, the addition of these three numbers. In this tutorial, we are going to define the continuous distribution. Let's assume that x is a random variable showing the heights of the individuals. If we study 100 people, we can find that, for example, 5 people has a height within this range between 5.5 to 5.75 inches. If we continue capture this data, we can build the continuous distribution. In continuous distribution, usually we fit a curve over the distribution because these numbers are so close to each other. The red line that defines the form of the distribution is called probability density function, or PDF, also denoted by f of x. In continuous distribution, the concept of probability is area under the curve. So when we talk about the probability of x getting a value within a range, we basically calculate the area under the curve. And that area is called cumulative distribution function, or CDF. There are a couple of differences between continuous and discrete distribution. So in discrete distribution, we can calculate the probability of x getting a specific value like 2. Also, we can calculate the probability of x getting a range of value like f of x less than 2. For f of x equal to 2, 16.1%, there is a chance that we get 2 6s out of 5 trial. For f of x less than equal to 2, we basically add these 3 bars and calculate the probability. And also, in discrete distribution, f of x less than equal to 2 is different from f of x less than 2. So f of x less than 2 doesn't include 2. It's a summation of these two bars in a purple area. and f of x less than equal to 2 includes 2, the red area. While in continuous distribution, we are only looking at the area under the curve. And the area under the curve for one number or one value is almost 0 because there is always one value higher than 2, like 2.00001, a small deviation from 2, and there is a number with a small deviation below 2, like 1.99999. So the area under this difference is so small and close to 0. There is no area under the curve for x being 2. Therefore, we can say f of x getting a single value is always 0 in continuous distribution. However, f of x less than equal to 2 is the area in the left side that we can calculate, and since the area under the curve for a specific number is 0, f of x less than 2 is same as f of x less than equal to 2. These are the main difference between continuous and discrete distribution in terms of calculation the probability when you are doing the work in Excel using Excel functions. Now let's talk about normal distribution. The normal distribution is one of the most widely used continuous distribution. It's a bell-shaped symmetric around mean distribution. It's also known as Gaussian distribution. So in the normal distribution, mean, median, and mode are in the middle and are the same value. Again, this blue line defines the shape of the distribution and is identified as PDF, shown by f of x using this function. Sigma is the standard deviation, mu is the average of the distribution, pi is 3.14, and e is 2.7 in this function. In order to calculate the area under the curve and calculate the probability of x getting a value within a range, we need to use the integral function. So if I can get the integral of this PDF, this line, for the area between a and b, then it gives me this area or the probability. Again, this blue line is the PDF defined by f of x. The area under the curve is called CDF. So for any x, we can calculate the area under the curve for f of x less than that value. Let's review the concept. Normal distribution is symmetric, so the skewness is 0. Every normal probability distribution is defined by its mean and standard deviation. Mean defines where the normal distribution is located. It can be any number, negative, 0, or positive. And standard deviation defines how spreaded this distribution out. For the lower standard deviation, the normal distribution is narrower. For higher standard deviation, the normal distribution is wider. So again, probabilities for normal distribution are given by the area under the curve within a range, and the total area under the curve is 1, or 100% there is a chance that x get any of this value. And note that this x-axis is the all possible value of x, and y-axis is the f of x. So in order to just make it simple, we show the normal distribution over x values. So the area under the curve is 1, and since normal distribution is symmetric, the left half area is 0.5 and the right half area is also 0.5. So again, the red line is PDF or f of x, the area under the curve is CDF or the probability, and from now on, instead of showing the frequency distribution in terms of bars, we only work with this shape for the normal distribution. There are two approaches to calculate the probability of x within some interval: traditional z-score and using z-table, or using Excel function. So in this tutorial, I'm going to only focus on using Excel function. Let's look at this example. Scores on management exam are normally distributed with a mean of 72 and a standard deviation of 8. We are looking at the probability that a randomly selected manager will score above 60. So we have a normal distribution with a mean of 72 and a standard deviation of 8, and we are basically looking at this green area for that probability. Now let's address this in the Excel. First of all, we need to define X as the score in the management test. Then we need to also identify the mean given to us as 72, and a standard deviation I will go with SD as 8. This is the area I'm looking for. Let's see if we can get the same number. First of all, we need to define the probability f of x being more than 60. I'm going to calculate f of x being less than 62. Again, less than or less than equal are same in continuous distribution. And second part asks us f of x being between 68 and 84. So for f of x less than 60, we are looking at this yellow area. We can directly use norm.dist, give the target value x as 60, the mean is 72, and a standard deviation is 8. Now we need to define whether it's cumulative or not. For the continuous distribution, it's always cumulative because we are looking at the range given to x. X can be less than 60, can be 59.9 or 59 or 0 or 1. So it's a range of value that is being assigned to x. Basically, we are adding up the probability that x is 60 or 59 or 58.5. So we are adding these probabilities. Therefore, we always use true. There is 6% chance, 6.6% chance that the manager will get less than 60 in the test. Let's look at f of x more than 60. So norm.this always gives us the left side area. In order to calculate this probability, we need to change it, transform this function or this probability to any kind of less than or less than equal. So I can say this is equal to 1 minus f of x less than 60. Why I can say that? Either the test score is more than 60 or this area or less than 60. The area under the curve is 1. So if there is 6% chance that yellow part is happening, therefore 1 minus yellow area gives me the green area. So 1 minus f of less than 60 gives me the green area. So now I can say 1 minus norm.dist 60 with a mean of 72, standard deviation of 8, and always true. Now there is 93.31% chance that the manager scores more than 60. Now we are looking at the probability that x is between 68 and 84, or the green area. So again, norm.this always gives us the left side area. Whenever we are looking at the between area, always we calculate the bigger area, the probability that x is less than 84, then we subtract the yellow area from this larger area. So larger area minus a smaller area gives me the between area. I can rewrite this as f of x less than 84 minus f of x less than 68. So I can say norm.dist 84, I have mean as 72, standard deviation is 8, and true. This time I'm choosing the cells, minus norm.dist 68, mean is 72, and the standard deviation is 8, and always true. So there is 62.46% chance that the manager will score between 68 and 84. With the same rule, we can introduce the empirical rule again. Empirical rule says that 68.3% of the data are within 1 standard deviation away from the mean, 95.4% are within 2 standard deviation away from mean, and 99.7% are within 3 standard deviation from the mean. This is very important, specifically when we are dealing with the statistical inference. Let's look at this rule with our example. So within 1 standard deviation is the probability of x being between 72 minus 8 and 72 plus 8. 72 minus 8, that's equal to 64 and 80. So 64 is 1 standard deviation below mean. 72 minus 8, 80 is 1 standard deviation above mean. That's 72 plus 8. So I can calculate this norm.dist, larger area, so we use larger number, 72, 8, and true, minus norm.dist, 64, 72, and 8, and true. So that gives us 68.3% almost of the area within 1 standard deviation, as you can see here. You can calculate the 2 standard deviation and 3 standard deviation also. I'm summarizing the Excel function that we used for calculating the probability. Whenever you see probability of x getting a value less than some number, you can use directly norm.dist, because norm.dist always gives us the left side area. If we are looking at the probability of the right side area, or x more than some value or right side area, you're going to transform it to any form of left side area. So this purple area is 1 minus this white area. So 1 minus norm.dist of x1 and then the rest of the function. So this part, norm.dist of x1 and mean and standard deviation true, is giving white area. 1 minus this white area gives us the purple area. And whenever you're seeing the probability of x being within some numbers, two numbers like x1 and x2, then you're going to calculate the larger probability, which is probability of x less than x2, minus the probability of x less than x1, or the smaller area, or this white area. So if I subtract this white area from the whole large area, it gives me the purple area. In the next video, I'm going to talk about exponential distribution and as the second famous continuous distribution.